Hi everyone. Now I am going to discuss about the circular kinematics or kinematics in circular motion. Okay, which are related to the motion in a plane. I am going to discuss, not related to the rotational motion. Okay. Now, first I am taking like whenever a particle is moving in a circular path, let us consider that this is starting from point A. At t is equal to 0, it is here. Now, if it is reaching to the at any time t point B, okay. Suppose say if it is turning through an angle theta, and r is the radius of the circle. Now you can get the relations like what is angle turned. Angle turned is nothing but it is a angular position. Also you can say theta is a angular position. If you want, you can write that theta is angular position. Angular position. Okay, at any time t we can say angular position. Now its SI unit is radian. It is a dimensionless quantity. Okay. Now same thing, if I take like this, any particle is actually moving from the certain point to the another point. Now see, initially it is having theta 1. Okay, now you consider this a t is equal to 0 degrees. Okay, now after some time it is moving to the certain location. At a time t, it is making angle theta 2. Okay, then we can see that displacement. The displacement from you consider the this is a point P and point Q. Okay, we can see the angular displacement can be written as angular displacement is, we can write delta theta is equal to theta 2 minus theta 1. For small angles we can write small angles, we can write d theta bar is equal to d theta 2 bar minus d theta 1 bar. Also you can write this is the angular position. You can observe that. Similarly, what is angular velocity? Angular velocity omega instantaneous can be written as d theta divided by the dt. Omega average value, if you want to write, delta theta divided by the delta t. Similarly, angular acceleration, we can see angular acceleration instantaneous value, if you want to write, that can be written as d omega divided by the dt, and alpha average value, if you want to write, we can write delta omega divided by the delta t. The same thing can be written as final angular velocity by initial angular velocity divided by the change in time interval. These are the relations we can see here, and whatever average angular velocity or angular velocity units are there, I will write that also. Here SI unit is radian per second, and SI unit of angular acceleration is radian per second square. Sometimes they will give like a 1 revolution per minute, RPM. 1 RPM is equal to, you can write it as first 1 revolution is 1 rotation can be written as 2 pi radians. 1 rotations per minute or revolution per minute can be written as 2 pi radian by 60 seconds. We can write it as pi by 30 radian per second. We can observe this. These are the revolution per minute and radian per second relation. Okay. Sometimes we can see that they will ask that what is the angular velocity of minutes and seconds and hours, and like that they will ask. I will write that. You know that for one full rotation, we can write it as whatever time period is there. That time period t can be written as 2 pi by omega, we can write. Otherwise you can write the r omega value, you can write it as 2 pi by time also, you can write that. I am writing now. I will write in next page. We can write for seconds pendulum or seconds hand. Seconds hand, time period is equal to 60 seconds. Then angular velocity can be written as 2 pi by 60 radian per second. Next, for minutes hand, we can write t is equal to 60 minutes. We can write the omega value is equal to 2 pi by 60. 60 minutes is nothing but 60 into 60 seconds. That is 3600 seconds. You can use the same thing here also, 3600 seconds radian per second. Similarly, for 12 hours clock, you can write time period is equal to 12 hours. 12 hours is equal to 12 into 1 hour is equal to, you can write it as 3600 seconds. So angular velocity can be written as 2 pi divided by the 12 into 3600 radian per second, you can write. Similarly, for 24 hours clock, we can write time period is equal to 24 hours, that is 86,400 seconds. We can write omega value is equal to 2 pi by 86,400 radian per second, you can write. This is about the angular velocity of the different hands, seconds hand and hours hand, like that. Okay, minutes hand, hours hand. Now we can see whatever 12 hours and this is like a hours hand I am writing. Hours hand. For hours hand I have written the time period. Okay. Now if it is moving, any particle is moving in a uniform circular motion, I am writing uniform circular motion. Uniform circular motion is nothing but if any particle is moving in a circular path with a constant speed. Particle moves in a circle with constant speed. We can see whenever a particle is moving in a circular path with a constant speed is nothing but we can see speed is only constant, but velocity is not constant. Velocity will change from point to point. Velocity changes. Velocity direction changes. Okay, and we can see there is always one acceleration will act. That acceleration, you can see that always acts towards the center of the circle. That acceleration is called centripetal acceleration. So acceleration direction changes. Now you can write it as centripetal acceleration is equal to v square divided by the r. We can write r omega square also you can write, where r is the radius of the circle. R omega square also we can write. And there is no tangential acceleration. This is what a tangential acceleration is. Tangential acceleration value is, we can write at is equal to rate of change in speed. This can be written as at is equal to d mod v bar divided by the dt, or we can write dv by dt, that is equal to r into alpha also you can write. So that value in this case is equal to how much? 0. At value is equal to 0. Tangential acceleration value is equal to 0 here. Okay, in uniform circular motion we can apply these relations. Similarly, next, non-uniform circular motion. Non-uniform circular motion. In non-uniform circular motion, we can observe that a particle moves with variable speed. Speed speed of particle changes. That is non-uniform circular motion. Now you can see whenever a particle is moving, let us consider here 2 meter per second is there. After some time, the speed will come like some other value. That value is v2 is equal to 4 meter per second will be there. Initially v1 you take. Now speed is changing continuously from point to point, it will change. In this case, we can see that in every case there will be two accelerations will be there. One acceleration which is acting towards the center is centripetal. One acceleration which is acting tangential to the circle is called tangential acceleration. There will be always net acceleration also we can observe. Okay. Suppose say if this net acceleration is making angle theta with tangent, we can write the angle also. Here speed changes. Obviously velocity changes. Acceleration changes. Acceleration also changes. Okay. Now you can write the relations. AC is equal to V square by R. That is also equal to R omega square. Next, AT is equal to R alpha. That is also rate of change in speed. Again, I am writing rate of change in speed. It is not velocity. Rate of change in speed. That is tangential acceleration. Now we can write the net acceleration value can be written as AC and AT both are perpendicular direction. We can write AC square plus AT square is the net acceleration value we can write. Here two things we can observe. Whenever a body is moving in a circular motion, particle what direction it will be there, I am writing now. Let us consider the speed increases. Speed increases. In that case, tangential acceleration, velocity same direction. Centripetal acceleration like this. This is a net making angle theta. Okay, in this case theta is equal to tan inverse of AC divided by the AT. Okay, AT and V are in same direction. I am writing AT and V bar are in same direction. Same direction. Similarly, if you take the any particle which is speed is this speed is decreasing. Speed is decreasing. If any particle speed is decreasing, we can observe that tangential acceleration value will be opposite direction. When speed will decrease, force is applied in opposite direction, then only it will reduce. No, that's why AT opposite direction. AC is like this. Net acceleration value will be like this. In this case, if you take the theta, now you can write theta is equal to, again you can write the tan inverse of AC divided by the AT. Here AT bar is opposite to the V bar. AT bar is opposite to V bar. Okay, this is actually relation when they are moving in a uniform circular motion as well as a non-uniform circular motion. We can observe these relations. Okay, next one, you can also observe like a relation between circular kinematic terms. What are the relations between the kinematic terms? I am writing now. Whenever a body is moving in a circular path, if it is moving in a circular path like this, if it is turning through an angle theta, moving certain speed, then if you want to calculate the what is the distance covered by the particle from A to B, R is the radius. Distance covered can be written as distance covered is S is equal to R into theta. If theta is equal to 30 degrees is there, then distance can be written as R into 30 degrees is nothing but 30 into pi by 180. That is S is equal to, we can write as R pi by 6. This is the distance covered. Example I am giving, just observe that. Based on the relation, you can follow that. Reason is 1 degree is equal to pi by 180 radian. Okay, next one. If you want to calculate displacement, how to calculate displacement? Just you make a right angle triangle here. If you make a right angle triangle, we can make this is the theta by 2 and the other angle also theta by 2. Now displacement can be written as AB a bar is that mod AB bar can be written as 2r into sine theta by 2, you can write. This is the displacement. Okay, similarly other relations you can see here, s is equal to, I have written r into theta, distance is equal to, now differentiate with respect to time. With respect to the time, we'll get the ds divided by the dt is equal to r into d theta by dt. We can write v speed is equal to r into omega. That's why till now I'm writing v is equal to r omega. Next one, differentiate with respect to time t. With respect to the time t, if I differentiate with respect to t again, I can get the dv by dt is equal to r into d omega by dt, provided r is constant. R is a constant. Now you can see whatever this is rate of change in speed. Rate of change in speed. Okay, so you can write it as a tangential acceleration is equal to r into alpha. This is one more relation you can observe. Okay, these relations we can follow whenever a body is moving in a circular path. Okay, next one, you can see other relations also when a body is moving with uniform angular velocity and non-uniform acceleration, non-uniform angular velocity, what will happen, and non-uniform angular acceleration, what will happen, we'll see. Okay, what equations of motion in circular motion. In circular motion, equations of motion in circular motion. First point, if a particle is moving with constant angular velocity, then you can write displacement is equal to omega into t. This is the only relation. T is equal to, you can write theta by omega. Next one, if a particle is moving with uniform angular acceleration, we can write it as omega is equal to omega naught plus alpha into t, omega t relation, this one, omega t equation. Next one, theta is equal to omega naught t plus half into alpha t square. This is the theta and t equation. Number of rotations is there, no, that rotations made by the body, that, and we can write omega square minus omega naught square is equal to 2 alpha into theta. This relation is for the omega and theta equation. Next, theta nth rotations made in a particular second or nth second, we can write it as omega naught plus alpha by 2 into 2n minus 1. Okay, these are the equations of motion when a body is moving in a uniform angular acceleration. Okay, next, third one, in non-uniform motion. In non-uniform motion, you can write this as omega is equal to d theta by dt, you can write. Similarly, you can write it as alpha is equal to d omega by dt, you can write. Similarly, you can write omega into d omega is equal to alpha into d theta also, you can write. These relations in the same manner how we have used in the kinematics, motion in a straight line, the same relations we can apply for the angular variables also. Okay, other than this, sometimes they will ask what is the directions. Now you see here, a particle is moving in a circular path like this. Now I am giving what is the directions. Now if any particle is just turning like this clockwise direction, clockwise rotation it is making, curl your right hand fingers, thumb gives the direction of the angular velocity. Angular velocity direction is this. Similarly, when a particle is moving in a anti-clockwise direction I have given. Now clockwise direction theta. If it is clockwise direction, curl your fingers, right hand fingers. Now we'll get the omega bar is equal to this. Now I am writing here motion is anti-clockwise direction, anti-clockwise rotation. Here clockwise rotation. In that case omega value downwards direction is there. You can observe that relation. Similarly, if you want to calculate omega direction also in the same manner, how omega value is changing based on that alpha value also you can write. Okay, more detailedly regarding the alpha particle we can discuss in a rotation chapter also. Okay, next one, finding radius of curvature. Finding radius of curvature. Just I am giving information which are the main points are there in this. Radius of curvature you can write it as if any particle is moving in a circular path. In circular path, radius is everywhere same only. Everywhere any point if you see, no, everywhere radius is r. Radius is constant. R is constant for fixed circle. Okay, now similarly if you take parabolic path, in case of parabola, you can see a particle is projected from certain point at different points. If you want to calculate this, it is projected with angle theta. Now it is going like this. In this case if you want to calculate radius, you can see at different points. Suppose if you want to calculate radius, here some radius will be there, center radius at this point. Suppose if you want to calculate radius at this point, you can see this is the radius. Okay, at different point different radius will be there. That's why I am calculating at highest point and at starting point. As you know, centripetal acceleration A perpendicular is equal to V square divided by the R is there. Or you can write R is equal to V square divided by the A perpendicular, or V perpendicular square by A also you can write. By using that relation I am writing, as G is having vertically downward direction, we can take the circle here. How this circle is there, you can see the circle is actually having center somewhere here. The acceleration at this point we can say that G cos theta is a perpendicular direction. U is like this. If I take this is A point, I am writing acceleration at point A is equal to, radius at point A is equal to U square divided by the G cos theta I can get. This is the radius of the parabolic path at a point A. Similarly at highest point if I observe that, now you can see at highest point velocity is only U cos theta is there, U sin theta value is there, no, that is 0. You can see G is acting downward direction. Now at point B I am taking this one. The radius of curvature at point B can be written as U cos theta whole square divided by the perpendicular acceleration is G. This is the radius of curvature at point B, you can observe. If you want to calculate radius of curvature at any other location, if I want to calculate radius of curvature at this point, you can see this side is G is actually downward direction, and this is making, suppose say alpha angle it is making. Now you can see if it is alpha 90 minus alpha, this is also alpha, you can write G cos alpha is a perpendicular. Okay, now you can write it as radius at point C I am taking can be written as V square divided by the G cos alpha, but I don't know what is a V value there, so I can write the V cos alpha is equal to U cos theta. Every time you can use that. Along horizontal direction Vx is equal to Ux. Okay, I can write V is equal to U cos theta divided by the cos alpha. you substitute there, we can get the u square cos square theta whole divided by the g into cos cube alpha. By using these relations also, you can calculate the radius of curvature at any point. Okay, next one, if you want to write any other thing, okay, like if y is a function of x is given, to find radius of curvature at any point, okay, any x, you can calculate the y is equal to 1 plus d y by dx whole square whole to the power of 3 by 2 divided by the d square y divided by the dx square. By using this expression, you can calculate the radius of curvature r. R value calculated as 1 plus dy by dx whole square whole to the power of 3 by 2 divided by the d square y divided by the dx square. By using this expression, you can calculate the radius of curvature for the given question. I hope you got the points whatever I have given. Okay, sometimes they will give like a time period relations, so many things they will give to calculate the time period or omega relations. Okay, I can write the relative velocity, relative angular velocity, angular velocity when times are given, time periods are given, time periods are given, or speeds are given. We can write omega a minus omega b can be written as 2 pi by ta minus 2 pi by tb, you can write. Okay, similarly r we can write it as to calculate the difference in time, you can write it as relative time interval. We can write the delta t can be written as 2 pi by omega relative, we can write. So I can write 2 pi by omega relative value is equal to omega a minus omega b, that kind of relations we can write. Okay, these are the relations you can observe carefully. Okay, now I am moving to the some questions asked in the JEE means, and if possible any JEE advanced questions are there, I will discuss now. You can observe. For a particle in uniform circular motion, the acceleration a bar at a point p r comma theta on the circle of radius r is, let us consider this is a circular path. This circular path, we can see a particle is moving and it is making angle theta. Let us consider the speed according to question is v is there. Now we can write the relations like this, making angle theta, v is like this, centripetal acceleration you can know that v square by r always act towards the center. Okay, now you can write the v square by r into cos theta left side, and v square by r sin theta is downward direction is there. If I write the acceleration value minus v square by r into cos theta I cap minus v square by r sin theta j cap, this is my acceleration value, we can observe. Okay, fourth option is the correct option. Next question, a point P moves in a counterclockwise direction on a circular path as shown in the figure. The movement of P is such that it sweeps out a length s is equal to t cube plus 5. The distance is given s is equal to t cube plus 5. You differentiate that, you will get speed. Speed is equal to, you can write 3t square, and if you want you can write acceleration also. Acceleration, whatever acceleration is there, that is tangential acceleration, tangent. So that is dv by dt, you will get the 60. Now as it is moving in a non-uniform circular motion, there will be net acceleration will be there, that value under root of ac square plus at square you can write. As per the question, they are asking at t is equal to 2 seconds they are asking. So v is equal to 3 into 2 square, we will get the 12 meter per second. Similarly at t is equal to 2 seconds, tangential acceleration value can be written as 6 into 2, that is equal to 12 meter per second square. Both the accelerations are there here. centripetal acceleration value can be written as v square divided by the r. V square value is 12 into 12 divided by the r value is, you can see, 20. R value is 20. You substitute the value under root of 12. If you calculate this value, you will get some result here. 12 into 12 divided by the 20 whole square plus 80 value is 12 square. You calculate, the value is coming nearest to the 14 meter per second square. Okay, first calculate the speed, then tangential acceleration. Again you have to calculate centripetal acceleration, v square by r. Okay, next question. A particle is moving along a circular path with a constant speed v is equal to 10 meter per second. What is the magnitude of change in velocity of the particle when it moves through an angle of 60 degrees? You observe this carefully. Whenever a particle is moving in a circular path like this, it is moving like this v, and it is turning through an angle 60 degrees. Now you can see same 10 meter per second it is coming here. Initially also 10 meter per second is there. Now I am taking initial velocity is vi, final velocity is vf is there. Now change in velocity can be written as v final velocity vector minus v initial velocity vector. If I take the v initial is upward direction is there, v minus vi will be downward direction will be there. That is 10 minus 10 meter per second. Now you can see this angle is 30 degrees, and if I make the angle is 90 degrees. Now angle between initial velocity vector and final velocity vector is 120 degrees is there. You can calculate the change in velocity vector magnitude can be written as under root of 10 square plus 10 square plus 2 into 10 into 10 into cos 120 degrees. If you substitute there, under root of 100 plus 100 plus 200 into minus 1 by 2, finally you will get the 100 root 100 value will get, that is 10 meter per second. Change in velocity value will be equal to 10 meter per second. Okay. Next question. Two particles A and B are moving on two concentric circles of radius r1 and r2 with equal angular speeds omega. At t is equal to 0, their positions, you can observe that their positions are along the x-axis. Now you need to calculate Va minus Vb at t is equal to pi by 2 omega. Means after 90 degrees turning, what is happening actually they are asking. We can, if you draw this diagram properly, now you can observe that after 90 degrees, particle A is there now. From here it will move to the this point. It is turning through an angle 90 degrees. Okay, so Va is equal to r1 into omega. Similarly, particle B is there now, that is anti-clockwise direction it is moving. We can see that particle B is moving from the this point to the certain location below this point. So particle B is coming this much angle. Now you can see particle B is equal to r2 into omega. Now I am writing Va bar is equal to minus r1 into omega bar I cap. Similarly, Vb bar is equal to minus r2 into omega I cap. Now Va bar minus Vb bar. Va bar minus Vb bar is equal to minus r1 into omega I cap minus r2 into omega I cap. You can write the value as r2 minus r1 into omega I cap you can write. You can see first option is the correct option. Okay. Next one. A clock has a continuously moving seconds hand of length 0.1 meter length. The average acceleration of the tip of the hand they are asking. Actually, whenever any hand is moving, seconds hand is moving in a circular path, whenever it is moving in a circular path, we can see the only force acting on this is only acceleration acting is centripetal acceleration. That centripetal acceleration value can be written as whenever it is rotating with angular velocity omega, L into omega square. L is given 0.1, Omega value, you know that for seconds and omega is equal to 2 pi by 60 radian per second. Substitute there 2 pi divided by the 60 whole square. Now you will get like a 0.1 into 4 pi square divided by the 3600 is there. Now you can write it as 4 will get cancelled 9 times. Pi square value is approximately 10, no? So we can get the 1 divided by the 900 value will get. 1 by 900 is approximately 10 to the power of minus 3 value order will get. Okay, in the order of like this, 10 power minus 3 will get. Fourth option. Next one, a body is rotating with angular speed. Initial angular speed is given 600 rotations per minute. Rotations per minute is nothing but 60 seconds. We can write 10 rotations per second. I am not actually keeping in any other radian per second. Reason is they are asking number of rotations only. Final angular velocity, you can write it as 1800 rotations by 60 seconds. So you can get the 30 rotations per second. Now they are asking time taken, they have given time taken is 10 seconds. Now you can calculate the theta value is question mark. To find the theta value, first you need to know the alpha value. Alpha value is final angular velocity minus initial angular velocity divided by the you can get the value is delta t. Final minus initial value, if you write that 30 minus 10 divided by the time is 10. So you can get the 20 by 10 is 2 rotations per second square. Use that omega square minus omega naught square is there, no? That formula. Omega initial minus omega final is there, no? That I am writing. Omega final square minus omega initial square is equal to 2 alpha into theta. Omega final square is 900. Omega initial square is equal to 100. That is 2 into alpha is 2 into theta. We will get the theta is equal to 800 divided by the 4. We will get the 200 rotations. Okay, option is 200 we have to mark. Next question. A ball is spun with a angular velocity acceleration. They have given angular acceleration is 6t square minus 2t. Now at t is equal to 0, angular velocity is given omega 10 radian per second. Angular acceleration, angular position also given 4. Most appropriate expression for the angular position they are asking. You know that d omega by dt is equal to alpha. So you can write it as d omega is equal to alpha into dt. Substitute there. Integral d omega is equal to 6t square minus 2t whole thing into dt. Integration I am doing. Initial angular velocity is at t is equal to 0. 10 is there. At any time t omega I am writing. So if you do that, omega is equal to 10 plus 6t square by 6t cube by 3. 6t cube divided by the 3 minus 2t square divided by the 2. This is the relation. Now again we know that d theta by dt is equal to omega. Now we can write integral d theta is equal to omega into integral dt. You substitute there. We can write a value of this d theta is equal to initial value they have given 4 radians. So 4 radians and final is theta. Omega value 10 plus 2t cube minus t square whole thing into dt. Integration 0 to we can write it as t. If I write that theta is equal to 4 plus 10t plus 2t to the power of 4 by 4 minus t cube divided by the 3. So if you do that, theta is equal to t square divided by the 2 minus t cube divided by the 3 plus 10t plus 4. This is a relation. You can observe that that relation is there in a second option. You can take that second option is the correct option. Okay. Next question. A person moved from A to B on a circular path. A distance covered is 60 meters. Angle is given 135 degrees. Just I am writing like a distance s is equal to r into theta. Distance is given 60, r value they have not given, theta value is 135 degrees is given. So 135 into pi divided by the 180. So we can write r value is equal to 60 into 180 divided by the 135 into pi, that is r value. Now earlier I have given what is the magnitude of displacement. Whenever it is moving, displacement value is displacement can be written as, you can write 2 into r sine theta by 2. We can write 2 into r value 60 into 180 divided by the 135 into pi sine of 135 degrees divided by the 2. You can calculate this value. You will get approximately 47 meters. You will get. Do the calculation. Second option is the correct option. They have given 135 degrees is 0.7, it seems. Cos 135 minus 0.7. Next question. A flywheel is accelerating uniformly from rest. Uniformly at rest means initial angular velocity is 0. Rotates through an angle theta is equal to, they have given 5 radian in time t is equal to 1 second. Okay, the angle turned by the flywheel in the next second is how much they are asking. You know that theta is equal to half alpha into t square, as omega value is 0. So we can write 5 is equal to half alpha into 1 square. So from this we can write alpha by 2 is equal to 5. Again I am writing initial value I have written like a theta 1 I am taking. Okay, theta 1 plus theta 2 I am taking, theta 1 is equal to 5. Theta 1 plus theta is equal to half alpha into t2 t square I am writing now again, t2 square. T2 square is nothing but actually t1 plus t2. T1 is 1 second, t2 is equal to much 1 second only. So t1 plus t2 is equal to 2 seconds. I am using that. Theta 1 is equal to 5, theta 2 I don't know. Half alpha alpha by 2 is 5. Theta 1 plus theta 2 is 2 square. I can get the theta 2 is equal to 20 minus 5, that value is 5 radians, 15 radians. Option 2 is the correct option. Okay. One last question. Two identical discs of same radius r are rotating about their axis in opposite directions. You can see here one is moving in anti-clockwise direction, and other one is moving also anti-clockwise direction. You can see. Okay, directions with the same constant angular speed omega. The discs are in the same horizontal plane. At t is equal to 0, the point P and Q are facing each other as shown in the figure. The relative speed between the 2 points P and Q is Vr. One time period t of the rotations of the disc Vr as a function of time is best represented by, they are asking. So now what I am doing is I will draw the redraw the diagram. You can observe this. From here they are rotating. Let us consider at any time t, this velocity is v1 is equal to r omega, turning an angle theta. And the second one also, if you see that it is turning certain angle, same theta angle I am taking, this velocity v2 that is equal to r omega. Now if I resolve the components along the x-axis as well as y-axis, if I resolve into x-axis and y-axis, how these values will be there? As it is theta, we can write this 90 minus theta, and this will be theta, 90 minus theta, this will be theta. Okay, theta theta. Here also theta is there. R omega cos theta, downside r omega cos theta in both the cases, and r omega sin theta, and this is r omega sin theta. Now you can see there is no relative velocity in vertical direction. Okay, now I can write relative velocity in y-axis is equal to 0. The relative velocity along x-axis can be written as r omega sin theta plus r omega sin theta. You will get the 2r omega sin theta. 2r omega sin theta. Now I am writing relations. If theta is equal to 0 degrees, we can write the v relative value is 0. If theta is equal to 90 degrees, we can get the v relative value is equal to 2r omega. Similarly, if theta is equal to 180 degrees, we can get the V relative value is equal to how much? Again it is 0. If theta is equal to 270 degrees is there, V relative value is equal to minus 2 r omega. But they are asking in the question the relative speed they are asking, but speed is always positive. V relative magnitude value is equal to 2 r omega. Similarly, if I write that if theta is equal to 360 degrees, again I will get the V relative value is equal to 0. Okay, so now you can see the sine graph we have to get. In one time period, you can see in one time period, you can see 0 is becoming 2 times, maximum value becoming 2 times. Okay, starting and at 180 and ending point also 3 times it is 0 is there, 2 times r omega is there. You can see 1 2 3, 3 times 0 and 2 times is the maximum value. First option is the correct option. A sine graph, observe this carefully. They are not asking the velocity, relative velocity, they are asking relative speed. Okay, speed is always positive, always positive. So first option is the correct option. I hope you have got this. This is about the lectures related to the complete motion in a plane. Okay, I have given the all projectile motions, even in circular kinematics also I have given. In the next video, I start the laws of motion chapter. I hope you have enjoyed this. Thank you very much.